Hey guys, welcome to Algebra 2, Lesson 7.3, Special Reference Triangles and Finding Exact Trig Ratios. Let's start with a quick warm-up. Question 1 wants us to determine what quadrant theta lies if the sine of theta is 2/5 and cosine theta is less than 0. So the first thing we'll do here quickly is jot down our ASTC, which if you remember stands for where the trig functions are positive. So the first one, it tells us sine theta is 2/5. I don't really care about the 2/5. I just know that it's positive. So I'm going to circle the two quadrants where sine is positive. Next, it wants to know where cosine theta is less than 0. So less than 0 is negative. You have to think about the two quadrants in which cosine is negative. It would be second and third quadrant. So my answer would be the quadrant we circled twice, quadrant 2. Question number 2 wants us to evaluate sine of 270 degrees minus cosine of negative 90 degrees. For this, I'll be using the unit circle. I prefer the unit circle over the sine and cosine graphs, but you can use either one. First of all, 270 degrees, where is that located? Right here. That has the coordinate 0, -1. The other thing we have to remember is that every single coordinate can be written as cosine theta, sine theta. So sine of 270 would be the second coordinate, which is the -1. So that gives me a -1 minus cosine of negative 90. Now cosine of negative 90 is also 270. Cosine is going to be the first one, so that's a 0. And that just gives me a -1. Now number 3 is a little bit more involved. Given the coordinate -5, -10, find the exact value of cosine theta. Well, first of all, that phrase exact value means you're going to have a fraction, most likely with a radical in it. And they give us a coordinate -5, -10. So that puts us in the third quadrant. So I'll just sketch my triangle in the third quadrant. -5, -10. And you always draw your angle theta to the x-axis. So there's my angle theta. And then we'll make a right triangle. Now, because I know the coordinates -5, -10, basically that means I went -5 in this direction. So this side of the triangle is just 5. And this side would be 10. Now, if you remember, cosine theta equals adjacent over hypotenuse. So the one thing we're missing here is the hypotenuse. So over on the side somewhere, we'll do Pythagorean theorem. 5 squared plus 10 squared equals x squared. 25 plus 100, that's 125 equals x squared. Square root that. It'd probably be best to simplify it. I'll do this quickly. That's going to be 25 and 5, and that's going to be 5 square root 5. So this side of the triangle is 5 square root 5, and now I can write cosine theta is adjacent, so it's 5 over 5 square root 5. And don't forget, because we are in the third quadrant, that's tangent's quadrant, so that means cosine is going to be negative here. So let's add the negative, and then we can just clean this up a little bit, divide both by 5, and I get -1 over square root 5. That's how I would leave it, unless it specifically tells you to rationalize the denominator. Okay, moving on. New material for today. Special reference triangles. I don't have time in this video to derive the ratio of these sides, but it's pretty neat and easy to do. But for now, I will just tell you what the ratio of these sides are. In a 30, 60, 90 right triangle, if we designate the smallest side as 1, the hypotenuse is always twice the smallest side. And then the side opposite the 60-degree angle is always the smallest side times square root 3. So you're going to recognize this ratio, 1, 2, square root 3, as the ratio of sides in a 30, 60, 90 right triangle. So if I were to make this side 3, the hypotenuse would be twice that, and then this side would be 3 square root 3, still in that same ratio. If I make this 5, then this is 10, and this is 5 radical 3. So that's how it always works for that triangle. For my 45, 45, 90 right triangle, notice it's isosceles, right? These two sides would be the same. So if I designate each one of those with a side of 1, using Pythagorean theorem, 1 squared plus 1 squared equals x squared. 1 plus 1 is 2. This side is square root 2. Now that's just the ratio. So same thing. If this was 7, that would be 7, and this would be 7 square root 2. Now I can use these ratios to come up with trig ratios for 30, 60, and 45 degrees. So you're going to see a chart sometimes, or there's other ways we can do it. Some of you will prefer using the triangles themselves, or just to simply memorize these values. So if we look at 30 degrees, 45 degrees, and 60 degrees, and we're looking at sine theta, cosine theta, tangent theta. So here's how the chart is going to work. Some of you will prefer to think of it this way. You're not going to have time to write this out for every single question, but it's just a way to help you memorize these. And this first one right here is one I highly recommend you memorize. So if you remember your SOHCAHTOA, which you definitely need to know for this unit, and you take a look at 30 degrees, sine is opposite over hypotenuse. So from here, opposite over hypotenuse, that's going to be 1/2. Well, cosine is adjacent over hypotenuse. So from 30, adjacent is square root 3. Hypotenuse is still 2, so that's square root 3 over 2. And there's a couple ways you can get tangent. One of the ways is to know that tangent is opposite over adjacent. So from 30, opposite's 1, adjacent square root 3. So that gets you 1 over square root 3. But you can also remember tangent is equal to sine theta over cosine theta. So you create a big fraction with these two, and then those denominators cancel out, and check it out. You get 1 over square root 3. So that's how you can remember that one. Now I'm going to stick with this triangle. So I'll skip over to the 60 degrees and do sine of 60. So now that's opposite over hypotenuse. It's still opposite over hypotenuse, but that side has shifted. So this is square root 3 over 2. Cosine would be adjacent, which is now 1 over 2. And now tangent's going to be opposite over adjacent, so just square root 3. So a couple observations here, which we'll point out in a second. Notice how sine of 30 is equal to cosine of 60, and cosine of 30 is equal to sine of 60. One of the things I remember, this is the hardest one for me to memorize, is the tangent. You see how tangent of 30 is 1 over radical 3. Tangent of 60 is radical 3 over 1. And the way I remember it is 30 degrees is smaller than 60, so tangent 30 will be smaller than tangent 60. Now the 45, 45, 90 right triangle is super easy because notice the opposite and the adjacent are the same. So sine and cosine are both 1 over square root 2. And tangent would simply be 1 over 1 or just 1. So, memorizing. Okay, here we go. Sine of 30 equals cosine of 60 equals 1/2. Sine of 60 equals cosine of 30 equals square root 3 over 2. Sine of 45 equals cosine of 45 equals 1 over square root 2. Tangent of 45 is just 1. The one biggie to memorize, if you're going to memorize one of them, this is what I do, and I base all my others off of this. Sine of 30 degrees equals 1/2. So when doing this, I can do it without drawing a triangle or thinking of a chart if I just remember this. So what I remember is if sine 30 is 1/2 and I have to find cosine of 30, I know it's not going to be equal to that. I do know these sides, so if it's not 1 over 2, cosine of 30 has to be the other side, square root 3 over 2. Likewise, if I have to find sine of 60 degrees, I know it's not equal to sine of 30, so again, it has to be the other side. So that's how I kind of go through to memorize all 9 of these values. All right, like I said, this triangle should be relatively easy. Okay, let's put it to practice here. Evaluate the following. Using the special right triangles, give exact answers. So we just discussed this. I'm not going to draw the triangles again, but you should have them maybe on a separate sheet of paper to reference, because these are things you need to be able to come up with without a calculator, because when it says exact that means either fractions and or radicals will be in your answer, not a decimal. No decimals. So that's how they get you to do this without a calculator. All right, so number 1, 2 times sine of 60 plus 2 times cosine 30. Well, sine of 60, if you look at that triangle on the other page, is going to be square root 3 over 2. Cosine of 30, well, guess what? That's the same as sine of 60, also square root 3 over 2. So now when I go to multiply these two things, this numerator and that denominator cancel out in both cases, and that gives me square root 3 plus square root 3, which is just 2 square root 3. Negative 1/2 tangent 45. Tangent 45, that's an easy one. It's an isosceles triangle, so that's just 1. Negative 1/2 times 1 is just negative 1/2. So as long as you know those trig ratios, these are really pretty simple. Question 3, we've got negative cosine 45 plus sine 45. Well, there we go. There's that isosceles right triangle. Cosine is 1 over square root 2, and sine is 1 over square root 2. So now we have negative 1 over radical 2 plus 1 over radical 2. That just gives me 0. Tangent of 30 divided by negative tangent 45. Tangent of 30, the way I remember it, it's the smaller one. So it's 1 over square root 3 divided by tangent of 45 is just 1, and it wants a negative. Well, that just equals negative 1 over square root 3. All right, so now we're going to combine the special right triangles with the unit circle that we talked about in the warm-up. So for question 5, I want 4 times sine 30 plus cosine 180. Well, the sine of 30, that's the biggie I told you to memorize, is 1/2. Cosine of 180, think about where 180 degrees is. That coordinate's negative 1, 0, and cosine is the first value. So that's a negative 1. And 4 times 1/2 is 2, plus a negative 1 equals 1. Next, I got cosine 270 minus tangent 45. To me, tangent 45 is one of the easiest ones to memorize. That's a negative 1. Cosine of 270, think about where 270 is right here. That coordinate is 0, negative 1, and cosine is the x value, 0. 0 minus 1 equals negative 1. Sine of 60, well, look at this one here. Sine of 30 was 1/2. So sine of 60 is not going to equal that. So it's got to be the other side, which is square root 3 over 2. Minus sine of 90. There's 90. That's 0, 1. Sine is the y value. So that's going to be 1. And because this has a radical and that doesn't, you can't mix these. All right, now theoretically I could get a common denominator, but that's not necessary. If you want to get a common denominator, what you would do is multiply this by 2 over 2, and then you could write this fraction as radical 3 minus 2 all over 2. So that would be okay, but this is also simplified. Tangent of 0 plus 3 tangent 60. So there's a couple ways you can remember this. Tangent of 0. There's 0. That coordinate's 1, 0. Is sine over cosine. So tangent of 0 is 0 over 1, which is just 0. The way I like to remember it is that on this right here, the slope is 0. And since tangent equals y over x, tangent is equal to the slope. So at both 0 and 180, tangent 0. Plus 3 tangent 60, which is square root 3. I got that from the triangle. So my answer is just 3 square root 3. Okay, so now we're going to talk about reference angles. A reference angle is the positive acute angle formed by the terminal side and the positive or negative portion of the x-axis it's closest to. So you always draw these to the x-axis. That means we're always using 180 degrees or 360 degrees. So the positive, I'm thinking how far the angle is from 360 degrees, and the negative, I'm thinking how far it is from 180 degrees. I'll draw these. I don't usually draw them, but I will for the sake of notes and to give you guys a better visual. So it says, give the reference angle of each of the following. 130 degrees. Well, where is 130 degrees? So if I were to draw 130 degrees, I know that that's in the second quadrant. This is the angle that's 130. My reference angle is how far that is from the x-axis. So I always ask myself, how far from 360 degrees or 180 degrees? Now, this is pretty simple math to do. I would just do 180 minus 130, and that reference angle is 50 degrees. Now, if you know this going in, it's not necessary to draw them, but for the first time going through, this might be helpful. 250 degrees. Where is that located? That is in the third quadrant. So the angle I want for the reference angle is this one. How far is that angle from the x-axis? So in this case, I just subtract 180. All right, and what's that, 70? So my reference angle is 70 degrees. Negative 30 is going this direction, 30. Well, that's already the reference angle. You just make it positive, because remember, it has to be a positive acute angle. So that reference angle is just 30. Negative 300, so you go around this direction 300 degrees. The reference angle would be to the positive x-axis. So in this case, I would basically add 360 degrees, and my reference angle is 60. So the reference angle is how far you are from either 180 degrees or 360 degrees. All right, that concludes day 3 notes. If you have any questions, don't hesitate to reach out to your teacher. Thanks for watching.